Tensees, hello, hello. Here we go with continuation of the polynomials units. We are still in factors and products. However, we are now getting into the second half of the units. Probably not quite as much time, but more important moving forward into the 20 level courses. We are going to get into factoring now. And factoring, where we have been taking polynomials of some size, and we have been doing things like FOIL, which takes multiple factors and creates one big term. We've been putting stuff together. We have AC plus AD. No, that's not what I want. We have 2 A's and 3 A's plus 4 C's. We've been combining like terms to get 5 A's and 4 C's. So far in polynomials, we've been putting stuff together. Well, factoring is the exact opposite. We want to take stuff apart. So what factoring is basically, instead of creating a product, we want to create a multiplication question. We want to do the exact opposite. Instead of putting stuff together, we want to take it apart. So something as simple as 24. You guys actually started factoring back about grade 3 when you had to take a number and write it as a multiplication question. Well, how can 24 be written as multiplication? Well, it could be 2 times 12. What we've done is we have factored the question because we created a multiplication, 2 times 12 for 24. Well, there's all kinds of possibilities when it comes to 24. There's 3 and 8. We could even say 1 times 24. As much as a lot of times we say, well, 1 doesn't do anything, there will be times multiplying by 1 does become important. We could also say something like 4 times 2 times 3. We could have 3 factors in the factored form. Factoring is about creating a multiplication question. If we took a look at 18x squared y cubed, well, we've been working with variables. So how could I create a multiplication question for 18x squared y cubed? Well, how did we get the 18? It could have been a 9 and a 2. How could we have created the x squared? Well, we could have had an x and an x in each of our factors, because x1 times x1 gives us the x2. How would the y3 have been created? Well, maybe y and a y2, because we would have added the exponents. So there's a multiplication question, 9xy times 2xy squared. That starts as 18x squared y cubed, and it can become 9xy times 2xy squared. Another possibility, there's all kinds of them. 6 times x squared times 3y cubed. There's a multiplication question. 6 times 3 is the 18. X squared times nothing, y cubed times nothing gives us our x squared y cubed. There's another multiplication question that could come from 18x squared y cubed. Factoring, that's what we've just done, is we have created a multiplication question. Well, we're going to work with not simple things like 24. We're going to work with, and not just things like a single variable, we're going to start to work with polynomials. Could be something like that. Multi-term polynomials that need to be created into multiplication questions. Well, there are 4 different factoring forms we're going to cover. GCF, greatest common factor factoring, we'll do in this lesson. There's simple trinomial factoring. There's the more complex trinomial factoring, and then there's the unique difference of squares factoring. Those are the 4 types of factoring we're going to cover. All of them are nice in that they follow very simple processes, but you have to make sure you practice the processes. This part of this unit is simply all about practice. And here we go. You need to know your basic facts. And you've been warned about that all year. Here it is in the course where it's going to become essential. So 4 ways of factoring, and we'll do a lesson on each of them. Today we'll start with greatest common factor, or GCF factoring. This is in the new booklet. If you haven't figured that out by now, the new booklet was posted. Whether or not you just follow along or you print it off, totally up to you. Now, greatest common factor factoring is a nice process, and what's important is every question that you get that says to factor, you should attempt GCF factoring first. It doesn't matter what's going on. If a question says to factor, you should always try GCF factoring before anything else. If you can GCF factor, it'll give you smaller values to work with. Now, the other thing that's important to understand with GCF factoring is you could do the process correctly, but still be wrong. Or rather, not perfect. You're not wrong, but there's always sometimes a better way to do it. And we'll take a look at that. So understand, please, that the checks are really important with GCF factoring. So let's take a look at this. We have 12x plus 18. The first thing we want to do is identify the greatest common factor. That's the biggest value that can be factored from all terms. Now, I refer to it as removing, can you pull out what amount from each term? When we do a GCF, we have to worry about the coefficients, the numbers in front, and we have to worry about variables. So to start with, let's worry about the coefficients. 12 and 18 in this case. So we need to identify what's the biggest value that's common as a factor to both 12 and 18. Well, what'll divide into 12 and 18? What's the biggest number? Well, this is where basic facts is important. 6 is the biggest thing that'll divide into 12 and 18 evenly. So there's the coefficient component of our GCF. The second part is the variable component. Again, I think of it as I want to pull out as many variables from each term. Well, how many variables are there in our 12x? We have a single x. We have an x to the 1. So there's an x term there that could be factored or removed from it. Well, how many variables do we have with our 18? We don't have any. So in this case, there are no variables common to both terms. So our GCF would just be 6. The variable component doesn't exist in this question because we only have one variable in one term. So our GCF is 6. Now what we're going to do is identify that 6 is the first factor in our factored form. We're halfway finished. How do I find the second part of the factored form though? Is I divide all terms by the GCF. And we've done polynomial division. So we want to divide this entire polynomial by 6. And remember, the 6 has to divide into each term, so I'm going to divide twice. 12x divided by 6. 12 divided by 6 is 2. x1 divided by nothing is still an x1. 18 divided by 6 is a positive 3. So there's my division, and there's the second factor. Make sure that you do finish by writing the factored form. We took the 12x plus 18, which was a two-term binomial, and we've now written it as a monomial times a binomial. It's now a multiplication question. There's the factored form. We've taken something and written it as a multiplication question. Now there's two checks that we can do. The first one is just multiply it. We don't have to do this. We don't want to put it back together, but it's a good way to check. If I took my 6 times 2x plus 3, and if I multiplied that, I'd have 12x plus 18. So what I have is the factored form does multiply to give me the original question. So I don't want that to be my answer. This is still my answer, the 6 times 2x plus 3, but there's a quick check to see what I have is correct. The second check is to check that there's no common factor remaining after I divide. So if I looked 2x plus 3, is there a common factor for 2x plus 3? The only thing that's common is a 1, and dividing by 1 in this case doesn't do anything. So we know our multiplication gives us what we started with. We have no common factors, so we know that 6 times 2x plus 3 is the factored form. Now, here's where I just want to touch. If I did 12x plus 18, and let's say for my common factor, I'm just going to do this again incorrectly. What'll divide into 12 and 18? Maybe all you can think of is a 2. There's an x and there's no x, so our greatest common factor is 2. Well, if I divide by 2, 12x divided by 2 is 6x. 18 divided by 2 is 9. Make sure you write it as a multiplication question. Well, in this case, if I did my check, here's what I think. Yes, I've factored it. I've created a monomial times a binomial. It is factored, but when I do my check and do the distributing, 12x plus 18, okay, my multiplication check is correct, but the second check was to see if there's anything else common. Is there anything common still to 6x and 9? Well, there is. I could still divide a factor of 3 from each of those terms. So because there's still something common there, yes, I have factored it, but not completely. So it's factored, but not to the extent it should be. But not as, I call it as small as possible. We, with GCF factoring, want to create as small values as possible, so our GCF of 2 isn't the best GCF. Go back to the original. Again, the best common factor is 6 because it creates the smallest values in our factored form. So that's what we have to be careful of with GCF. Sometimes we can factor it and we get a factored form that works, but it's not 100% best answer. And that's what we always want to look for. So let's take a look at the next one. 24w cubed xy squared plus 16w squared x squared y cubed plus 8w squared x squared. Lots going on here. We want to create a multiplication question. It's the same thing. First thing is identify the GCF. The GCF, remember, coefficients and variables. So if I take a look at the coefficients to start, 24, 16, and 8, what's the biggest value that'll divide into those? because that'll be the biggest factor that we can factor out from each term. And in this case, it's 8. 24 divided by 8, 16 divided by 8, 8 divided by 8. That's the biggest value. But now we have the variable components. So we have to consider, we have w cubed, w squared, and a w squared. What are the most w's that could be factored or removed, pulled out from each term? W cubed is like 3 w's, w squared is 2 w's, w squared is 2 w's. So the most w's that can be pulled out of each is a w squared. Even though there's 3 w's here, I don't have 3 w's here. So the greatest factor that's common to all of them is a w squared. And now we just keep doing the same thing with all the variables. Here we have an x to the 1, an x squared, and an x squared. What are the most x's that could be factored out of each term? 1x, 2x's, 2x's. Well, the most that can be pulled out of each of them is an x1. So x1 is part of our GCF. And then when it comes to the y's, we have a y squared, we have a y cubed, and we don't have a y. Now some kids start to look and say, oh, I'm just going to look for the smallest exponent, y2, y3, 2's the smallest, that's what's part of our GCF, but it isn't, because there is no y. So in this case, no y in the GCF, 8w squared x is the greatest common factor for all those terms. Now what do? We divide by the GCF. So this entire expression, has to be divided by 8w squared x. And every term, like always, has to be divided. So I like to write it underneath each of them just so I don't make mistakes. Remember, 8w squared x is our first factor, and now I'm finding the others. 24 divided by 8 is 3. w3 divided by w squared, subtract exponents, and it's a w1. x1 divided by x1, subtract exponents, it's x0. We don't even need it. Y squared divided by nothing leaves us with a y squared. And I need to do that for the next term as well. 16 divided by 8 is a positive 2. W squared divided by w squared is a w0. I don't need it. X squared divided by x1. 2 minus 1 leaves me with an x1. Y cubed divided by nothing. Still have a y cubed. And the last one, third time, 8 divided by 8 is a 1. W squared divided by w squared. 2 minus 1 is just a w1. Sorry, it's a w0. My bad. 2 minus 2 is 0. Sorry. So there is no w. X squared divided by x1 is x1. And there's no y, so I don't worry about it. So there's my factored form. 8w squared x times 3w y squared plus 2xy cubed plus x. I've created a monomial times a trinomial. There's the factored form of it, and away we go from there. Monomial times a trinomial. I can multiply in my head really quick. Yes, I get the original, so my multiplication will work out, and I have nothing common in each of these. 3, 2, and 1, no common coefficient. W, no W. No W is common. Y squared, Y cubed, no Y. Nothing could be factored out. I've correctly factored. Make sure you write it in factored form. Trinomial becomes a monomial times a trinomial. So let's take a look at a couple more together, and then you'll have lots of time to practice. So here we go, a little bit quicker. Negative 6c minus 4c squared. Here's a special situation for identifying the GCF. The only time negative is the GCF is if all terms are negative. So in this case, our GCF will be a negative GCF because both the negative 6 term and a negative 4 term. So GCF will be negative. What's the biggest thing that'll divide into 6 and 4? Well, that's a 2. Look at the C's. How many C's are common to both terms? I have C1 and a C squared. The most C's that can be pulled out of each is a C1. So negative 2C is the first factor in our factored form. And now I divide the binomial by negative 2C, which means each term gets divided by it. Watch your signs here. Negative 6 divided by negative 2 is positive 3. C1 divided by C1 is a C0, nothing. Then negative 4 divided by negative 2 is a positive 2. C squared divided by C1, subtract exponents, we get a C1. And there's our factored form. The only time the negative's in the GCF is if all terms are negative or special situations that we'll talk about in other cases. Right now, the only time negative is in the GCF is if all terms are negative. Try E. Maybe stop it, give it a try. We'll talk about it. Here we go. GCF. Coefficients. 5, negative 10, negative 5. They're not all negative, so 5, 10, and 5. 5 is the biggest coefficient that will divide into all of them. We have a y1, we have a y1, and we have a y1. How many y's could be factored out or removed from each term? A y1 could be removed from each term. After that, I have z's and a z squared, but I have no z, so my GCF is 5y, and that's what I'm going to divide by. Every term needs to divide by the 5y. 5y is one factor, and now I find the others. 5y, 5 divided by 5 is 1. y1 divided by y1 is a y0. It's important to put the 1 in. We have to have that. Anything 5y divided by itself is 1. It's going to be in our factored form. Negative 10 divided by 5 is negative 2. Y divided by y is a y0. Z divided by nothing leaves me with a z. Negative 5 divided by 5 is a negative 1. Y divided by y, 1 subtract 1 gives me a y0. But z squared divided by nothing leaves me with a z squared. So my factored form is 5y times 1 minus 2z minus z squared. There's your factored form. Monomial 5y times the trinomial. It's important if we get a value of 1 that it is there, because when I multiply 5y times 1, I need that 5y value there, so I have to keep the 1 placeholder. So that's all there is to GCF factoring. Identify your GCF, divide by the GCF. Here's your assignment, booklet page 29, all of it. All right, the work is there, the answers are there, and if you pull out and take a look at the answer sheet that I have included, I think you will find my work is not there, but if you have questions, we can always talk about it. Then you have textbook, a few questions. Textbook, especially 14 and 16, a little bit bigger. 14 is a little unique, a good one to take a look at. And at the back of the booklet, you will find pages 59, 60, 61, I think 62. There is a whole bunch of factoring questions. Factoring is 4 little processes that require practice. So if you want extra practice, my suggestion is start with page 59, the left side, which I think is called page 61 actually, in the photocopy. This is just about identifying the GCF. This is the important step that I find students struggle with. So this extra practice, it's up to you. Depends upon whether or not you want to be totally on top of this. So give this a try. Make sure you do this assignment. The factoring is not difficult, but you need the repetition, repetition, repetition. So have fun with it, and we'll talk soon if you got questions.